Hello, and welcome to our look at measurement, specifically starting with units of length. As always, we review our curricular outcome first. So, our curricular outcome. Students will be able to solve problems that involve linear measurement using SI and imperial units of measure, estimation strategies, measurement strategies. So let's take a look at some units of length we should be familiar with. The base unit, that's the meter, which was originally defined by Napoleon Bonaparte. He hired a scientist to figure out how long it was, but the definition was Napoleon's. That was 1/10,000,000th of the distance from the North Pole to the equator. The current definition is the distance light travels in a vacuum in 1/299,792,458 seconds. It can be modified by your usual metric prefixes, so the meter can become the centimeter, the kilometer, the decimeter, millimeter, so forth. The most common prefixes are milli for thousandths, centi for hundredths, deci for tenths, deca for 10 of, hecta for 100 of, and kilo for 1000 of. If you get into computer science, mega, giga, tera, and now peta are becoming a lot more common. So those are our next most common. Mega is 1,000,000 of them, giga is 1,000,000,000, tera is 1,000,000,000,000, micro is 1,000,000th, nano is 1,000,000,000th, and pico is 1,000,000,000,000th. And the prefixes are defined for every 3 exponents of 10, every 3 place values, from 10 to the 30 to 10 to the negative 30. So let's take a look at some other units in the history of units. Historically, we started with reference, frequently based on body proportions. So not a formal unit of measure, but something you could refer to. For example, an arm of rope. In this case, people would buy from taller vendors in the market for a better deal, just their arms were longer. It was sort of functional in the market, but it's terrible for science because there is very little or no standardization. We needed to develop something more consistent and reproducible from written descriptions so that we could share them over long distances and come up with the same value. The metric system is now the system used by science. There is a YouTube video I share in class that doesn't work when I'm posting to YouTube, but I believe that's the Tom Teaches Science. Now, the imperial units of length. The current definition of imperial lengths starts with the inch, where 1 inch is 2.54 centimeters. Then 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 5,280 feet, or 1,760 yards. You might have heard 5 tomatoes to remember 5280 for the number of feet in a mile. Still prefer the metric system where you're just shifting the decimal place. So why do we have 2 systems? The metric system, or the Système International, was developed in France. France and the UK didn't always get along. So the United Kingdom created the imperial system to have a system that is independent of France's systems, and that was a decision driven by politics, not by a need from math or science. The imperial system is the standard system of measurement in the United States of America, Liberia, and Myanmar. The rest of the planet either has dual standards, accepting both, or they are all metric. The UK is one of the ones with a dual standard. All other countries are metric. Imperial used to be much more common, but during the 20th century, a lot of the world switched to metric. So there are also base units. All units of measure are made from 7 base units. Every other unit of measure is some combination of these. For length, it is the meter. For mass, it's the kilogram, which is the only base unit with a metric prefix. That K for kilo. Chemistry uses the gram as its standard, but everything else, it's a base unit without a prefix. Mass is the only one with the prefix. There's time, that's the second. Temperature, that's in Kelvin. Current, that's the ampere. All other electromagnetic measurements are combinations of the ampere and other measures. For quantity, it's the mole, which you will see in chemistry classes, if not now, then very soon. Think of it like a really, really big version of a dozen. There's also luminous intensity, the candela. You don't run across that very much at all. So, examples of how to use these. So let's find some examples of objects with the following measurements. 0.1 millimeters, 1 inch, 1 meter, or 2 meters, and 3 kilometers. Well, there's a lot of correct answers for each of these. The 0.1 millimeters could be width of a hair. 1 inch, it could be the distance between the knuckle and the end of the thumb. 2 meters, that could be a tall person. 3 kilometers could be the distance from home to school. These ones do not have a single right answer. So others, thickness of a piece of paper, width of a nylon eraser, height of a door, distance from home to a grocery store. Okay, example 2. Explain why this cartoon is considered funny, at least by some people. So water, 1 mile or 1 kilometer. The Americans will take the more familiar route. They think, oh, it's only a mile. A kilometer is shorter than a mile. 1 mile is about 1.6 kilometers. So that is the big difference. So people do tend to stick with the familiar. All right, let's do some exercises. Provide examples of objects with the following measurements. 7 centimeters, 15 feet, 27 meters, 1.4 kilometers. So you can pause and think about it to come up with some answers. But again, there's a lot of right answers. So we don't have definite answers there. Okay, so define and create a new length measure. Figure out a new unit. For this, you need to come up with something that is clearly defined on paper and not like a new prefix, not saying, oh, it's 42 meters or 6-7 meters. No, something different that's standardized. Turns out it's a little tough. But it has to be reproducible based exclusively on the written description. So you can text someone on the other side of the world and they will come up with the exact length you suggested. In summary, we have a wide variety of units of length available for us to work with. The metric system is the official standard in Canada and most of the world, particularly in science fields. From here, if you have any questions, any feedback, leave it in the comments. I will do my best to respond in a timely manner.